Yes, students. Today we are going to discuss paper 2. That's the electron deficient compounds or the chemistry of boron that we were discussing. Different compounds of the boron. That's a BF3, BCl3, BBr3. By the way, BH3 also. All were expected to be the Lewis acids. But among them, who will be the strongest Lewis acid? Why it is so? That we have to discuss today. Before to start today's session, I like to remind you the concept of Lewis acid. Lewis acid means a species. It may be the molecule, it can be ion, which can accept lone pair of electron. To that we say as Lewis acid. Now, in case of these boron compounds, say for example BF3, if their boron undergoes sp2 hybridization, three fluorines are there, trigonal planar means a triangle you have to consider at the end of or at the apex of one triangle, one fluorine, second apex, second fluorine, third apex, third fluorine. It's an understanding about the BF3 molecule, or it is like a fan, ceiling fan, or any three-bladed fan you can consider. It's a trigonal planar molecule. There, boron remains with one vacant orbital or empty orbital. And because of that empty or vacant orbital, compounds of borons are Lewis acids. I remember that electronic configuration also I have shown to you. Hybridization also I represented, and I said that one empty orbital, say 2pz orbital, do remain present on the boron, and that empty orbital can accommodate two electrons, can welcome lone pair, and because of welcome to the lone pair by the compounds of boron, that compounds of boron like BF3, BCl3, BBr3 or BH3 are Lewis acids. Students, is the concept clear? Okay, Nishan, Shubham, Saurabh, Jelina, Prathamesh, Urmila, yes, all are saying yes, it is clear. Okay, all students are replying. Very good, very good. Now see, I start the presentation. Yes, please reply. Could you able to see the screen? Is it
Yes, sir.
readable? Very good, very good. I magnify it further. Brilliant. Okay. If you want this document file, I will upload on our Google Classroom so that you can go through these contents. These many reactions by the red ink that you are finding, the explanation, these are only for the reference purpose, not directly for the study purpose. For point of interest is structure and bonding in the boron compounds. Say example BF3. If you see the boron, atomic number of boron is 5. So electronic configuration 1s2, 2s2, 2p1. In true sense, in ground state, boron is with two vacant orbitals, two empty orbitals. But just before few minutes, I said boron remains with only one empty orbital. It is due to excitation of the electron. It is due to the hybridization concept. The electron in the lower energy level, say 2s energy level, excites to one of the 2p. Because of that, the two empty orbitals whichever were there in boron, electrons are there in the boron. And those three unpaired electrons can form three bonds, and there are three fluorines. Each fluorine is with one unpaired electron, so each fluorine can form one bond. So likewise, three fluorines can form three bonds, and trigonal planar structure is represented. But if you observe this diagram neatly, a wave kind of structure, a brown or yellow kind of the curves are represented, and if you read those curves properly, curve starts from lone pair of fluorine and ends there. See, arrow is there towards boron. So lone pair can migrate to boron. This orbital, which is this orbital? It is vacant or empty orbital, whichever is present at the boron. Because of that, we say it is expected to be the Lewis acid. But having its a genuine or original acidic behavior, something different occurs here. And the different behavior is this back bonding. is this p pi overlap. I repeat, the covalent bond boron fluorine is shown by a dashed line. But in addition to covalent bond, there is a likelihood of overlap of field to pz orbital of fluorine and empty to pz orbital of boron. Because of field to pz orbital of fluorine, the electron region will move to the vacant portion, means how the wind moves, where there is a high pressure. From high pressure to low pressure, the wind goes, wind blows. Water, how does it move? From the high level to the low level. So waterfall that we can realize. So electron from where can move, where electron rich situation is there, from that electron poor situation. I'm not understanding what's the problem, because I'm admitting Shubham, but he could not get admitted. Okay, we'll attempt again. So we were expecting this covalent bond, it's a fine. But in addition to this covalent bond, there is an interaction, overlap between the field orbital of fluorine, which was not involved in the bonding, which is the lone pair, and vacant or empty orbital of the boron. So just I said, from high level to low level, from high pressure to low pressure. Likewise, from electron rich region to electron poor region, electron will move, electron will transfer. So because of that, the interaction or overlap of pz orbital occurs. So in addition to our usual covalent bond, that's a boron fluorine covalent bond, there is an additional p pi bond, p pi back bond. Now question is, why back bond or why back bonding? That back bonding because the fluorine generally is electronegative. So electronegative means it should have a tendency to take electron, get electron, fetch electron, rather than giving electron. So basically, by nature, fluorine is not generous. Fluorine is not noble. Fluorine is not the donor for the electron. It is lower to the electron. It can gain electron. It can accept electron. It can fetch electron. Despite of that, what are we finding here? Overlap of the field and empty orbital takes place. Whatever the inductive effect is there, whatever the induction is there, whatever the electronegativity difference is there, because of that the gain of the electron is that will be forward the fluorine in case of this covalent bonding. But whatever this upper bond that by brown color or by yellow core is represented, it is a reverse kind of the bond. Generally what we say, water from river goes to the ocean or the sea. But if high tide is there, then water from ocean or the sea can come to the river. Means there's a creek region that we say, no? So no statement is perfectly or absolutely right. So inductive effect phenomenon, absolutely it works, certainly it works. But because of richness, it's the high tide of the electron pool, electron level, electron from fluorine comes to the boron. Yes, students, please reply. Are you understanding? Though the fluorine is not generous, here electrons are migrating, electrons are moving from, electron region is coming from fluorine to boron. Are you understanding?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good, good. See, please go on replying. No, be honest and prompt to reply. One reply I got immediately. Very good, brilliant. So, but due to which what happens? Completely hunger of this p orbital is not fulfilled. Still, that p orbital is with scarcity of electron. Still, that p orbital can welcome the lone pair. It is an additional portion that because of this fluorine it gets that. Means it is not the complete lunch that orbital of boron gets. It is just a snacks that's a fluorine to offer. So snack is not a lunch, you know. Because of snack, the hunger cannot be fulfilled thoroughly. So what is the hunger of that pz orbital is there, vacant orbital is there, the need of that vacant orbital is there, that can be fulfilled by lone pair only, and that lone pair From where can we get? We can get that lone pair from other donor. So it may be the fourth of fluorine. That's a BF4 minus also. The fluorine or say fluoride, F minus. That also, or NH3 also, ammonia. In ammonia, nitrogen remains with the lone pair, and that lone pair can be launched at what boron. But suppose boron gets already snacks, then the hunger will be less. So eager to take that lone pair will be less. Yes, students, I want your help now. I want your reply. Suppose if hunger of boron decreases, eager of boron to take lone pair decreases, then Lewis acidity will increase or decrease?
Decreases.
Brilliant answer. It will decrease. As a general answer point of view, if you go to the net, no, very wrong things are given there. Misleading facts are given. Actually, those are not facts. Those are what the misleading ways. What they have said, few were general indirect effect they are applying. Fluorine is more electronegative, and because of more electronegativity of fluorine, electron from boron will be shifted to toward the fluorine, and because of the scarcity of the electron, the boron will feel more hunger, and boron will attract the lone pair more eagerly. So BF3 should be the strongest acid. Likewise, explanation they have given, which is absolutely wrong. Reality is BF3 at the first instance we expect to be the strongest acid, but it is as we expect that much strong it is not, because it is getting snacks, it is getting little energy level, little electrons from fluorine, and because of its hunger is not completely quenched, it is decreased, and because of decrease in hunger, its Lewis acidity is less than our expectation. Now, additional logic I inform to you. Listen carefully, and if it is not clear, bring it to my notice. I like to compare this BF3 with other compound, say BCl3. Difference is, in spite of this 3 fluorine, 3 chlorines will be there. I want answer from you students. Among fluorine means F and chlorine means Cl, who is more electronegative? Now, if you talk, then I could able to listen because I am presenting now. So I had opened other window. Is my question clear? Students, am I audible to you?
Yes, sir.
Yes, sir.
Okay, what happened? I am not getting answer. Yes, Prathamesh, you want to talk?
Fluorine, sir.
Right. Fluorine is more electronegative than chlorine. So as per our general logic, I am saying it is not perfect. The fluorine is more electronegative, so fluorine will take more electrons. So BF3 should be more acidic than BCl3, which is not true. On the basis of electronegativity, we can't conclude. Electronegativity factor is there, but which factor is dominating? Dominating factor is a p-pi back bonding. Now, answer for my question. In case of fluorine, last electrons are present in which orbital or which sublevel?
2p.
Exactly, 2p. Similarly, about chlorine, in case of chlorine, which orbital will be there? Yes, in case of chlorine, which orbital will be the outermost orbital, where electrons are present, where lone pairs are present?
3p.
2p. Exactly, 3p. Fluorine belongs to second period, second shell. Chlorine belongs to third period, so third shell will be there. So 3p orbital. Yes. Now 2p and the 3p. If you see at the center nucleus, around that the 1s, 2s, 2p like orbitals are there. The p orbital has dumbbell shape. So 2p orbital has one particular kind of size. 3p orbital has also particular kind of size. I want answer from you. What do you think? Which orbital will be larger, 2p or 3p? As the shell number increases, as the distance from the nucleus increases, size will increase. My focus here is on the 2p orbitals and 3p orbitals. And I am asking you about among these 2p and 3p, which orbital is larger?
3p.
Exactly, 3p orbital. And if larger the orbital is there, it will keep some distance, no? For example, in case of the see in school days, before the school begins, there remains a prayer or common instructions remains. So at that time, generally teacher asks, have a distance of one hand. So if a tall person is there, then the length of the hand will be more, distance will be more. If a short boy is there or girl is there, short student is there, then the distance compared to others will be what the less. Fluorine has the maximum orbital, it's a 2p orbital, highest orbital is a 2p orbital where electrons are present. So size of the fluorine is smaller and size of the 3p orbital here in case of the chlorine will be what the larger. So size point of view, chlorine will be what the larger. So the atom three-dimensional aspect. So if I have to compare what you can say a cricket, tennis ball or leather ball you can consider, and other can be what the handball or volleyball. Handball size remains somewhat smaller compared to what the volleyball. So handball will be more perfect. So relatively size of the chlorine is what larger. And what is happening? Volleyball is going to interact with the tennis ball. Is a one situation. In case of boron and chlorine bond. And in case of the boron fluorine bond, tennis ball is going to interact with the tennis ball. So that interaction is relatively stronger. Which one? Tennis ball interaction with tennis ball. 2p orbital interaction with 2p orbital. In boron, 2p orbital is present here. 2p orbital. So 2p orbital let you consider for this covalent bond also. For hybridization, those 2p orbitals are involved. So 2p and 2p, a strong interaction will be there. Energy level difference also matters. Later on, when you will study in deep, that's a molecular orbital theory. Actually, you have started to study energy level matters. If nearby energy level, more interaction will be there. Strong overlap will be there. So strong overlap is there in case of the boron fluorine because a type of orbital is same 2p and 2p. But if you take about the BCl3 molecule, the one orbital is a 2p and other orbital is a 3p. One orbital has one kind of energy, other orbital has other kind of energy. Difference in energy, extent of interaction, extent of bonding, extent of overlap will be different. So in case of BCl3, extent of overlap is less. Extent of overlap is less. So accordingly, pi bonding, back bonding also will be the less. So in case of BCl3, that back bonding is less compared to BF3. As back bonding is less, electron is boron is getting less number of electrons, so its hunger increase. So when BF3 is there, more snacks are available. And in case of BCl3, less snacks or the little food only is given. So hunger of boron is relatively larger in case of BCl3 compared to BF3. Therefore, BCl3 is the strong acid compared to BF3. If I continue this ideology for the next molecule, that's a BBr3. I hope you will understand. Bromine means there 4p orbital will be there. 4p orbital means further larger. Means if you consider olive oil, then it's a further larger, means a balloon as like you consider, no? Likewise, that's a 4p orbital of the bromine will be there. So where is 2p orbital and where is 4p orbital? Energy gap lot of is there, and because of more and more energy gap, extent of interaction will be less. Extent of interaction is a less. Back bonding will be the less. Back bonding is a less. So snacks given are further less. If they are more less, their hunger of boron will increase, because anyhow that acidity is due to hunger of boron. Acidity is due to empty orbital present in the boron. In case of BF3, more snacks will be there, less hunger. In case of BCl3, less snacks are available, little more hunger. In case of BBr3, further lesser snack because interaction is less between the boron and the bromine, and due to which BBr3 is further stronger acid. So students, is the sequence of acidity clear to you? BBr3 is the strongest than BCl3, which is stronger than BF3. Is it clear?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Good. See here. One interesting diagram is represented. In case of BF3 also one diagram was there. Let me see. whether it's now available or not. First, let me explain for the BF3, and then I come to the BCl3. For BH3 also, let me have the discussion. So BF3 and BF4 minus, that formation I'm searching now. Here these reactions are there just only for the reference purpose. How it is important, for that purpose only those reactions are given. Okay, fine. I magnified further so that you can read that bond angle also proper. See, BCl3 molecule originally is a trigonal planar, and NH3 molecule is approaching. NH3 molecule in that nitrogen is a donor, and that lone pair of nitrogen can come to the p orbital of the boron. This is a situation. As this bond formation takes place, the bond length increases. See here, previously boron fluorine bond length was 174 picometer, but as it forms adduct or coordinate compound with NH3, sorry, the bond length has increased. What does it signify? It signifies that chlorines are larger. So as ammonia comes, among them the repulsion or steric hindrance has taken place, and due to which the geometry also change. Please, if anywhere the mic is on, switch it off, turn it off. Okay, thank you. So here what happens? The tetrahedral geometry you are finding, means whatever blade was, three blades of fans were there, now those are bended because of the pressure, because of the load of the ammonia molecule, or the size of that the ammonia molecule, as well as the chlorines also were the larger. In case of fluorine, what happens? That much size of fluorine is not there, so repulsion is not there. Means if you take a small ball, and around that if you consider a tennis balls, and upside if any large molecule comes, repulsion place. But if you consider holy balls are present around upside also something comes out there, repulsion will be considerably more. And because of that change in geometry and change in bond length, that signifies there is a repulsion between the chlorine and incoming ammonia molecule. Okay, so the sequence of the acidity that I represented, see, BF3 is a weak, then the BCl3 which is weak, then the BBr3. These notes I'll provide to you. I'll upload in the Google Classroom. Okay. Afterwards, we need to study such electron deficient compound where banana bonds are there. Interesting thing, banana bonds are there, or bridged bonds are there. So what exactly that phenomenon is, that we will study. Before that, I like to ask you, whatever I discuss now, is it clear?
Yes, sir.
Yes, about the Lewis acidity. In that you can add about BH3 also, and you can compare. Once the base is clear, you will what understand. So now let me explain this banana bonding. Actually, two BH3 molecules are there. If you observe here, I have just magnified this diagram. Could you able to read the diagram clearly?
Yes, sir.
Yes, sir.
Yeah. From this diagram, what you can find? Two borons are there. I consider this boron as a left side boron and other boron right side boron. Actually, compound of borons are BH3. One boron is related to 3 hydrogens. Similarly, other boron also related to 3 hydrogens. Imagine this T kind of arrangement. This is one hydrogen. Opposite to that HB that you are finding, bridged hydrogen, upside hydrogen is there. That is the second hydrogen. And perpendicular to the line joining of these 3 hydrogens and boron, there is a third hydrogen. So a T kind of the arrangement of BH3. Yes, students, could you able to understand that T kind of arrangement in case of BH3?
Yes, sir.
Okay,
yes, sir.
very good. Similarly, see here the T kind of arrangement. Here lower hydrogen is the bridged hydrogen. Then boron. Continue that line, you will find one more hydrogen. And perpendicular to this line joining of hydrogen, boron and hydrogen, which I considered now, there is a third hydrogen. It is represented here. So here is a second BH3. These two BH3 are united. They are bridged. They come together and you get one molecule, that's a B2H6 molecule. This is called diborane. and bonding in diborane that we are studying. Again, pay the proper attention. Total how many hydrogens are there? 6 hydrogens are there. What is the formula? B2H6. So 6 hydrogens are there. Out of those 6, how many are terminal?
4.
Right, see
4.
here. This is one hydrogen, second hydrogen, third hydrogen, and fourth hydrogen. Read this diagram carefully. What are the boron hydrogen bond is shown by dash. This also is shown by dash. This also shown by dash. This also shown by dash. What does it mean? All these terminal 4 hydrogens, boron, they are in one plane, and that plane you can consider a plane of the screen or plane of the paper or plane of the board. So they are in one plane. So you have to under 2 borons are there you have placed on the screen, or slate if you have taken, or paper you have taken, keep 2 borons, and for each boron these 2 hydrogens are making V kind of the arrangement, angular, as like water molecule remains, no? Likewise these terminal hydrogens are there. So all these 6, which 6 atoms? Terminal 4 hydrogens and boron atoms, they are in one plane. Sorry, they are in one lamina. Students, are you understanding a planar arrangement of terminal hydrogens and borons? If I need to repeat, you can say accordingly.
Repeat once.
Yeah, listen carefully now. At the beginning I said the 3-blade fan I asked you to imagine, no? Now imagine only 2 blades of fan. Second blade there is a hydrogen, and boron blade fan means out of the 3 is a modified fan. Second fan you have to consider. Head of the fan, 1 blade terminal hydrogen, second blade terminal hydrogen, and third blade which was expected, it is absent. So these blades of the fan, first blade, second blade, third blade, fourth blade, and heads of the fan, that's a boron, all are in one plane. All these 4 blades and these heads are in plane. All these 4 hydrogens and these 2 borons, they are in one plane. Plane means a lamina. A leaf you can consider, or page of the notebook you can consider, or board you consider, or screen you consider. So what I am asking you to imagine, consider these 4 hydrogens, terminal hydrogens and borons on a screen. Could you able to imagine?
Yes, sir.
Yes, very good. Now, next imagination. I am asking these bridged hydrogens to imagine. Out of these 2, one is upside and other is downside to the screen. And suppose if you are seeing now the screen of mobile or a PC, then on the screen we are considering what? 4 hydrogens and 2 boron. And what about these bridged hydrogens? I am asking you to imagine one of the bridged hydrogen towards your side. Means here I am observing the point I am showing, and other hydrogen is behind the screen. So these 2 bridged hydrogens are there, they are in one line, but one is upside and one is downside. So these 2 hydrogens are not in the plane of these 4 hydrogens or 2 boron. One is towards us, consider, and one is away from us and behind the screen. It's the imagination. Could you able to imagine this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So whichever the 6 hydrogens are there, those are divided into 2 parts. One part terminal hydrogen, those are in plane, and other part bridged hydrogen, those are not in the planes of those terminal hydrogens. One is above the plane and other is below the plane, behind the plane. It's a 3-dimensional imagination or understanding. Now whichever these bridged hydrogens are there, those do bind, those do link to both boron, this boron also and this boron also. So it is like a bridge links, no? One bank of the river and other bank of the river, one boron and other boron, and that is linked by means of what? Bridge. So this hydrogen works like a bridge, or this is said as bridged hydrogen. So here bridged kind of bonding is there. Actually it is a electron deficient bonding. It is a banana kind of bonding. Just listen these words. I'll explain them in detail later. So these bridged hydrogens, is one category and terminal hydrogen is the other category. Now pay attention towards bond length. Bond length with terminal hydrogen is 119 picometer, boron hydrogen bond. And boron hydrogen bond length with bridged hydrogen is 134 picometer. Here B came mistakenly there. Now answer for my question. Which bond is weak? Bridged hydrogen bond and boron bond is weak, or terminal hydrogen and boron bond is weak?
Terminal.
Terminal
Terminal is
hydrogen.
why? Whoever said terminal, why terminal is weak? Reason. We are studying science.
Bond length is small.
Yes. Bond length is small, so bond is weak. Bond will be weak or strong. If bond length decreases, bond length decreases, bond distance decreases, atoms are coming closer, then bond strength, friendship will be less or more.
More.
Yes. So bond length is less, so bond should be stronger. Bond length is more, bond should be weaker. So answer was reverse. Is it clear?
Yes, sir.
Smaller the bond length,
Yes, sir.
stronger will be the bond. Larger the bond length, weaker will be the bond. Here, terminal hydrogens are with small bond length. Therefore, terminal hydrogens are forming strong bond with boron, while bridged hydrogens are forming weak bond to each boron. Number one. Second, see a terminal hydrogen, the bond angle is 120 degree. Means as like example of fan, the blades are separated by 120 degree. Out of those three blades, only two blades we are considering. So 120 degree separation is there between the boron and the terminal hydrogen. Or between the two terminal hydrogen bonds, 120 separation. While aboveness and belowness by which angle? See here. It is just a complete aboveness and belowness is 97 degree. If you take the half of this, means 48.5. So if you consider plane, their borons are there. So to that plane, just make an angle of 48.5 degree upside is towards us. You will find one hydrogen, and behind the plane, behind the screen, just go by 48.5 degree. You will meet second hydrogen, second bridged hydrogen. So total angle between those two bridged hydrogens, because one is behind and one is here, so that angle will be double than the 48.5. So that's a 97 degree. So this angle is what represented. So it is what the bonding present in the or structure of this B2H6 molecule. I repeat, in B2H6, two types of hydrogens are there, terminal and bridged. 4 are terminal, 2 are bridged. All 4 terminal hydrogens and borons are in one plane or on screen or on board, and bridged hydrogens are away from the screen, means maybe above and one is below. What's the bond angle between the terminal hydrogens? It is 120 degree. What's the bond length of boron and bridged hydrogen? 134 picometer. What's the bond length of boron and the terminal hydrogen? 119 picometer. Terminal hydrogen bonding is less, so they are strongly bonded. Hydrogen borons are near and it is weakly bonded. Now we have to find the reason why this boron and bridged hydrogen bond is weak, or boron and terminal hydrogen is strong. This bond is strong, this bond is weak. That we have to find out now. For that, the electronic configuration is necessary. That point I explained shortly, and we will stop our discussion. Afterwards, the session I'll keep open for you for questions. Now, I want your help for description. What is the atomic number of hydrogen?
One.
If you have yes. If you have notebook, then write down 1. Hydrogen 1. Write electronic configuration 1s1. Hydrogen is with only one electron. So how many bonds hydrogen can form?
1.
Right, 1. So hydrogen is forming here the one bond. But about bridged hydrogen, something difference is there. But keep in mind, hydrogen is with the one electron. When this bond formation takes place between the hydrogen and the boron, now this boron has how many electrons? That let we find. I want your help now. What's the atomic number of boron?
5.
Right, 5. So electronic configuration 1s2, 2s2, 2p1. But when bonding occurs, outermost orbitals, see listen, orbitals are involved. Outermost shell electrons are involved. Answer for my question. In outermost shell of boron, how many electrons are there?
1.
3.
Right. 3 electrons are there. So boron should form how many bonds?
3 bonds.
Right. As per our usual common sense, those 3 electrons. 2 electron investment is here with terminal hydrogens. 1 electron from boron goes or forms bond with this terminal hydrogen. Second electron of this boron will form bond with this terminal hydrogen. Now answer for my question. Out of those 3, how many electrons are left on this boron?
1.
Yes, keep in mind now. Keep in mind. Here this boron has property of 1 electron. Left boron has 1 electron. Similar ideology you can apply. Similar logics you can apply and you will understand. This boron, right side boron also is with 1 electron. Could you able to understand 1 electron on this boron?
Yes.
Yes. So this boron has 1 electron, this boron has 1 electron. So count is now 2 electrons. About hydrogen. Hydrogen has how many electrons?
1.
1. This hydrogen also has 1 electron. So answer for my question. Now in this region of bridged bonding, 2 borons and 2 hydrogens, how many electrons are there?
4.
Right, 4 electrons are there. Generally we form bond by one bond by means of 2 electron. Here see, in case of terminal bonding, 1 electron from boron, 1 electron from hydrogen. So here 2 electrons are involved. Terminal bonding, 2 electrons are involved. But here what are we finding? Atoms are 4, electrons are 4, and number of bonds, if you observe neatly, here there is a dot 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 1 bond, dot 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 second bond, here dot 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 lower third bond, dot 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 is a lower bond, that's a 4th bond. So 4 bonds are there and electrons are 4. Till now 2 electrons, 1 bond we have considered, but here case is different. I explained more deeply now, more correctly. Here boron is 1 electron, hydrogen is with 1 electron. This boron also is the 1 electron. This hydrogen has 1 electron. What happens there? There remains a mutual understanding between the borons. What this boron says, example, I will take care for upper hydrogen, upper bridged hydrogen. So this boron takes care for upper bridged hydrogen. By the way, with other boron also bonding is there. How it is possible that I discuss later. While this right side boron says I will take care for lower hydrogen. So this boron bonding you are finding is there, but how, that we will understand. So whatever the 1 electron with boron is there can form only 1 bond, but because of the good understanding between the 2 borons, that borons are united, borons are together, borons have the synergic moment, and what that boron says, this boron forms bond with the upper hydrogen. So we were expecting a only dash here, but it is not. There's a good understanding. What this boron says, partial overlap, let I also do have. I also want the share of the electron from the hydrogen, or whatever the electrons are there, let we share completely. So what is the situation? I like now regular college is not there, but in case if regular college would have been there, you would have brought the tiffin, and suppose in the tiffin you would have brought the chapati. So boron is with the 1 chapati, hydrogen is with the 1 chapati, means 1 electron. This boron at this moment for this kind of bonding, at this situation, there is a no chapati, but boron is a friend. So what will you do? Even you are the 3 friends, then among 3 you will share those 2 chapatis. Likewise, among 3, electron from boron, electron from hydrogen will be shared. Here, this boron is not contributing. Now, second time what happens? See, other situation. This boron says, last time, this boron says to the other boron, last time you have contributed. So this time I will contribute. So chapati is brought by this boron. Chapati is there with hydrogen, but now chapati is not left because whichever was there is involved in bonding. So lower bonding occurs between boron, hydrogen, boron due to electron from boron and hydrogen. Now, more deeply I'm saying, this boron is with one electron, this hydrogen has one electron, and this boron at this moment has no electron. So three centers are there, three nuclei are there, three atoms are there, but electrons are two. And among them understanding takes place. Let us share those two chapatis within three, two electrons within three. So centers are three, but electrons are two. So here, this kind of bonding is called banana bonding. It is called as three-centered two-electron bond. This kind of bond, terminal bond, two-centered, two-electron. How many centers are there? Those electrons are there. Here, centers are more, electrons are less. Similarly, for lower bridge, electron is from this right side boron and electron is from lower hydrogen, bridged hydrogen. So two electrons are there, but that share of this electron goes here to boron also, because boron undergoes sp3 hybridization. Out of that sp2 hybridization, already you have studied, if sp3 then 4 orbitals will be there. Out of those 4, only 3 orbitals have the electrons. So in case of this boron, this orbital has electron, this orbital will not be with the electron. About right side boron, upper orbital is with no electron, but lower orbital is with what? The electron. But whichever the orbital has no electron but will overlap. Here electrons are there, but that overlap is not only related to this right side boron, bridged boron, lower boron. It's a good friendship is there between boron, lower hydrogen and boron. So here total 2 electrons are there, but centers are 3. It is called three-centered 2-electron bond. So similarly, this boron contributes here now electron, hydrogen contributes electron, but right side boron doesn't contribute. Here 3 centers are there, but 2 electrons are there. So again, second 3-centered electron bond. So this 3-centered 2-electron bond is called electron deficient bond. And because of that, we say this diborane compound is electron deficient compound. Now, to the conclusion portion I am coming. Here see in case of terminal hydrogens, answer for my question, this BH-T bond, boron and terminal hydrogen bond, how many electrons are there? Help me. This boron and terminal hydrogen, how many electrons are there?
2.
Please repeat. Boron and hydrogen, terminal bond, in this bond only, how many electrons are there?
2.
Right, 2 electrons. How many centers are there? How many atoms are there for that bonding? For this
2
bond?
atoms.
Right, 2 atoms. So 2 center, 2 electron bond. While here boron is a 1 center, hydrogen is a 2nd center, right side boron is a 3rd center. Here 3 centers are there. How many electrons are available? Upper bridge.
2 electrons.
Right, here 3 center 2 electron. So where are electrons less? In bridge bonding electrons are less, or in terminal bonding electrons are less?
Bridge bonding.
Right, because of that electron deficiency we say, electron deficient compound we say. Now, electrons are going to have the friendship, orbitals are going to have the friendship. Here only 2 electrons are involved, so, but 3 centers are there. And here 2 electrons and 2 centers are there. So which bond will be the healthy bond? Which bond will be the strong bond? Terminal hydrogen or bridged hydrogen?
Terminal hydrogen.
Right, terminal hydrogen strong bond or bridge hydrogen weak bond. And because of that weak interaction, relatively weak interaction, bond length for bridged hydrogen is larger, is more. That's a 134 picometer, while terminal it is a 119 picometer. Yes, students, structure and bonding in diborane clear?
Yes, sir.
Yes. Now I stop this sharing the screen. I come to our usual screen of the lecture. Yes, if you have any doubt or any question, feel free to ask. Maybe on the topic that I discussed just now or previous topics also. Yes. If no question, shall we stop now? Yes, Shilpa, good. Yes, recording of this by night, I will make it available. I stop the recording and I declare here today's lecture is over.